All right, guys. So I'm going to go over this review and practice with you for the test. So it's over key characteristics of quadratic functions, which is what we have been learning about. So let's do it in orange. So hopefully at this point, you know what the standard form of a quadratic function looks like, and that is f of x equals ax squared plus bx plus c. And whenever we were doing the key characteristics and I was asking for a equals, the only thing that I need is that a value. I don't need that x squared, and the only thing I need is that b value and that c value. Those are the only parts that I would need if I were to ask you a question like that. So now we're going to answer some questions about the following quadratic functions without using a calculator. So this is stuff that you should be able to do without picking up a calculator or Desmos. So number one, we're looking at f of x equals negative 2x squared plus 2x minus 3. So is it going to open up or down? And this one is going to open down. And we know that based off of that negative in front of our a value. Our y-intercept, we know that it is at negative 3, or you can also write 0, negative 3. I will accept both. And we know this because of, maybe I should change the highlighter. I'll give you a little interesting notes. Because of that negative 3 on the end. Because with our standard form, we know that we can look at our c value, and that is our y-intercept. So a lot of people have also been struggling a little bit with axis of symmetry. We wrote those formulas down on the first day in the notes, and it was that x equals negative b divided by 2a. And whatever you do, do not forget that negative out front. That negative is what's messed up a lot of people's answers. So if we're looking at this specific equation, we're going to have negative, and our b value is 2, divided by 2 times our a value, which is negative 2. So on the top, we'll have negative 2, and on the bottom, we'll have negative 4, which will end up giving us positive 1/2. So, and the very, very important thing about knowing your axis of symmetry and getting it correct is that x equals 1/2, that 1/2 is the x value of our vertex. So we need to know how to find that axis of symmetry correctly to be able to get the correct value of our vertex. Because if you don't get the correct x value of your vertex, you're not going to get the correct y value of your vertex. And to get this correct y value, you're going to plug in that x value into our original equation. So I'll probably write it up here. So we're going to be looking at f of 1/2, and that is negative 2 1/2 squared. I guess we're going to write on top of number 2, and we'll come back and erase this. So 2 times 1/2 minus 3. So you can either type this in a calculator if you want to, or you can solve it by hand. So we're looking at negative 2. 1/2 squared is 1/4. Plus 2 times 1/2 is 1 minus 3. So we're looking at negative 2 times 1/4, which will give us, I want to make sure I'm giving you all the right values, which will give us negative 1/2 plus 1 minus 3. And negative 1/2 plus 1 minus 3 will end up giving you negative 2.5, which can also be written as negative 5 halves. All right, so I'm going to go ahead and erase this that's over here for our next problem so that we can solve it. Fabulous. Let's solve this one in purple. We'll probably bounce around with some colors here. So if we're looking at number 2, f of x equals 1/2 x squared plus 5x. So are we going to open up or down? Hopefully you recognize that this one is going to open up because we do not have a negative out front. Our a value here is positive. Our y-intercept this time, so our c value here is 0, because remember we can add on 0 to anything and it's not going to change it. So our y-intercept is at 0, 0, or you can also just tell me 0. I will take both of those. Axis of symmetry here, again, it's that x equals negative b divided by 2a. So that negative b is going to be negative times 5 and 2 times 1/2, which is going to give us negative 5 divided by 1. And then my final answer there will be negative 5. For our vertex, remember this x value from our axis of symmetry is giving us our x value vertex. So we're looking at negative 5, and then we have to plug that in. So we'll plug it back in up here. So we're looking at f of negative 5. So 1/2 negative 5 squared plus 5 times negative 5. I don't disappear, but I know what I'm talking about. So negative 5 squared is going to give us 25, but we have half of 25. Plus 5 times negative 5. It's actually not going to be a plus because it's going to be negative 25. So we're looking at 25 divided by 2 minus 25. So this will end up just being negative 25 halves. I'll write it if you really want to see it. All right, hang on. Let's go ahead and close out that parenthesis there. So we have our final vertex there. And guys, please, 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 if you're going to remember anything for this test, just remember your axis of symmetry and your vertex. That is going to just give you so much information here. So to wrap up all this information about standard form, how can you tell whether a quadratic function is in standard form will open up or down? And that is based off of our a value being positive or negative. Guess I should have started farther over. How can you identify the y-intercept of a quadratic function in standard form? So this is your c value, or it's going to look like 0c. How do you find the axis of symmetry of a quadratic function in standard form? That's at x equals negative b divided by 2a. That is so important. And then how do you find the vertex? You then plug in your axis of symmetry. To get your y value. All right, so then down here we're asked to sketch a graph for each function. On your graph, label the y-intercept, x-intercept, maximum, minimum, and you can use a calculator. So I'm not going to use a calculator to start this out, but at the end of this video, I am going to pull up the calculator on my computer and show y'all a few things. So I'm going to just graph this straight by hand, but I will show you how to use the calculator later. So the first thing we need to do is kind of find our vertex here. So again, it's at negative b divided by 2a. So negative of negative 2 divided by 2 times negative 1. I'll have positive 2 on top and negative 2 on the bottom. So we're looking at where x is negative 1. I would then plug in my calculator where x is negative 1. And you will get 4 as your vertex. So I would go to negative 1, 4 and plot a point. I would then probably be very smart and look to see if I can look at my y-intercept, which I would label as well while I'm at it. And we're looking at 0, 3. So I would probably use my axis of symmetry, which goes straight down to get my other point, which is going to be negative 2, 3. And I would go ahead and graph this. To get your x-intercepts here, you could plug in 0 for x, which in your calculator would then give you, oh, you can't plug in 0 for x, actually. You plug 0 in for y. Ignore me. You can plug in 0 for your y-intercept. You would actually need to look on your calculator or on Desmos to find your x-intercepts, which I'm going to go and tell you it is 1 and negative 3. And I will show y'all how to find those here at the end. And then I would also probably write up here that my maximum point, because I have a maximum here because my graph is opening down. And I believe that's it. We have our maximum, x-intercepts, and y-intercepts, and we got a graph. So we're good there. So now let's go look at We'll do it in orange. I'll make my pen a little smaller too. So now we're going to look at number 4. And again, we're going to have to do negative b. And our b value here is 4 divided by 2a, which is 1/2. So you would end up getting negative 4 divided by 1, which then gives us negative 4. And when you plug that back in, you're going to get negative 8, or you should. So that means we have negative 4 and negative 8. And it's a good thing this is positive and opens up because we couldn't graph much more down. So I can go ahead and tell you that our y-intercept is going to be at 0, 0 because our c value is 0. Which, and I'm going to actually draw my axis of symmetry on here so we can visually see. So we went 1, 2, 3, 4 to the left. So we can go from the axis of symmetry and go 4 to the right. So 1, 2, 3, 4 to the right. And the nice thing about that is this also is giving us our x-intercepts. So one of our x-intercepts is 0, 0, and the other one is negative 8, 0. And then I would also label this as our minimum point. And then we're good to go for that first page. All right, so now we're going to talk a little bit about vertex form. Personally, my favorite form. So hopefully at this point you have recognized that f of x equals a parentheses x minus h squared plus k is that vertex form. So then we're asked to determine the vertex of each of the quadratic functions in vertex form without using a calculator. And hopefully you remember that our vertex is h comma k, so all we got to do is find our h value and our k value. So the very important thing here, though, is to don't forget about that negative inside. So our literal h value for this first one is positive 3, and our k value is positive 8, because similarly out here it is that plus sign. For, which I guess is, we're going to call this one the second one over here. This time our h value is negative 4. And that is because we have a positive sign in there, and that's opposite from our form. And then we're just going to bring down our positive 2 because k is just exactly as you see it. So down here we have 1, negative 8, 2, positive 6, negative 9, negative 1, and finally negative 5. And remember, we can add 0 on 0. All right, so as I'm filming this, I just realized I gave my in-person kids a number 5 that is not on the one that is in Kidam. So the one that was given to the in-person students was about writing an equation in vertex form for a quadratic function that satisfies each of the given characteristics. And I gave you a vertex and just said the parabola opened up or down. So I'm going to do one over here on the side, and I'm just going to do one, and I'm just going to write it in red so you'll have an idea of what you may see. So say I gave you that your vertex is negative 1, 4, and your parabola opens down. So, and that's all you're going to do. So you're just going to write f of x equals, and if the parabola opens down, we know that we need a negative a value. So you can write any value that you want. I mean, I could write, I'm probably going to put negative 2x plus 1, because we got to do opposite because we're on the inside, squared plus 4. So that's all you have to do. You can pick any value for your a value just as long as you keep that negative because we are opening down. The number 5 that y'all have, so now we're talking about transformations of necessary to translate the graph from f of x into the graph g of x. So pretty much what you need to grasp from this is that negative is going to turn our graph, it's going to open down. That negative 2 inside is going to take us right 2, and that negative 4 is going to take us down 4. So this is the exact same thing as absolute value. It's just with a quadratic instead of a absolute value. Down here, our graph is going to open up we are going to go left 3 and down 3. We're not going left 3, sorry. We are going left 5. Left 5, down 3. Down here, again, we are going to open down because of that negative a value. We are going to go right 1 and up 4. And then finally, we're not going to flip up. We are still going to be opening up. We're not flipping. So we're still going to open as I write down. Losing my mind, guys. We're going to open up again. We are going to go left 2 and up 1. And you can still draw arrows on here if you like that, but just make sure you can verbally say it like you're going left 2, up 1. So I understand what you're talking about. So how do you identify the vertex of a quadratic function in vertex form? So the vertex is going to end up looking like hk. Our x is our h value, and our y is our k value. So how do you tell if a quadratic function opens up or down in vertex form? The same as last time, our a value. If it's positive, we open up. If it's negative, we open down. How does the a value transform our quadratic function? It can reflect it. It will also vertically stretch it or vertically compress it. But the main thing that I want y'all to really be able to see is if we're reflecting it. As our h value is what's going to take us left or right. So in absolute value, this is our c. And then our k value takes us up or down. And that was our d value in absolute value. All right, so finally we're on to our last form, that factored form. Hopefully, again, y'all can recognize by now that factored form is when we're looking at f of x equals a x minus p x minus q. And again, be careful because of those minus signs. They like to get y'all. So open ups or down. Again, it's that a value that we're talking about. So this one is going to open down. And our zeros are our p and q values. So our p value here is 4, and our q value is -8, not +8. So our zeros are 4, 0, and -8, 0, which zeros also mean x-intercepts, solutions, or roots. All those are the same things. I think I forgot to cover zeros, but that is what they are. Just another way to say it. So, and then if you flip over, just kidding, that's a completely different problem. That's number 8. Let's do number 7. So is this one going to open up or down? It should open up. Oh, again, mine changed. What are we doing? This one will open up, though. Our p value here is -2. Our q value is +2. So this one's going to open up, and our zeros are going to be -2, 0, +2, 0. For number 8, we are opening down. Our zeros are -1, 0, and 7, 0. So if you don't want to write down your little p and q values, just remember to think the opposite. And then finally, we are opening up again, and our zeros are -1, 0, -6, 0. So, and I had another number 11 on the review that I gave to the in-person students, and it was, again, just writing a quadratic function in factored form to represent a parabola that, we'll do this one that opens downward and has zeros at -1, 0, and 8, 0. So we just wrote f of x equals, and because we're opening down, we just got to make sure that it's negative. So we'll do -4x plus 1, because we got to do the opposite with those values. I'm going to write down here a little bit. And x minus 8. So you're just writing an equation. Your a value can be anything. Just make sure that your sign on your a value is correct, okay? So how can we tell if the graph of quadratic function in factored form opens up or down? Again, this is our a value here that's important. It's on every single one of them. I can identify zeros of a quadratic function. It's that p comma 0 and that q comma 0. Determine, let's see, did I have this one on mine? I did not have this one on mine that I did in class. It was with axis of symmetry and all that fun stuff. Yeah, I guess we didn't do that in class, so we're not going to worry about those. So finally, graph of quadratic functions. We're looking at this what is given to us. Our domain is all real numbers. It's those two lines and kind of a curly R, or you can write all real numbers if that makes you more happy. And that's because our arrows are going out for forever and ever and ever, so we're going to have all x values. Our range, so some people are struggling with range, and this is when y is greater than or equal to -9. And the reason for that, so you kind of got to look at this, and I always think about it verbally, but all of our y values are greater than -9 here. So because the y values are greater is y, it is going to be y is greater than or equal to -9. Our x-intercepts are right here, and they are 0, 0, -6, 0. Our y-intercept is 0, 0. Axis of symmetry, x equals -3. Our vertex is at -3, -9. Our interval of increase, so that's when we are increasing. So how I like to think about it is if I were to put my pen up here and draw, I'm drawing down until I get to our turning point. And then at that point, I turn and go up. So we are increasing for when x is greater than -3, and we are decreasing when x is less than -3. And we do talk about our x, we talk about our domain when we're talking about increasing and decreasing of intervals. So we have the same last page. So there were only those two little things that kind of got a little crazy on us. So for 4 and 5, you can use a calculator. I used a calculator for mine. I'm going to go ahead and write the answers down, and then we'll do these on the calculator that I'm going to pull up here in a second. If I'm recording it on Word and have this calculator, my computer is going to crash. So I will pull it up, but I'm going to go ahead and write down the answers here. So the answer to 4 is 7.5 seconds. And the answer to 5 is 1.198 seconds. Which that is also something you could look up on Desmos. And all that fun stuff, which why we're on this page actually. So it says circle the buttons for the calculator. Which button we use for a variable? The button that you're going to use for a variable is this xt theta n button. The exponent one, so you can click this to get any exponent that you want, but since we're dealing with quadratics, you're really just needing that square that's also right there. And then our negative button down here is very important as well, because if you click minus instead of negative, it will not graph this. So we got to make sure that we're using the right buttons here. So let me open up my computer. I'm going to pull up my calculator. What was it called? Maybe I typed in TI. SmartView, that's what it is. So let me go ahead and get out of here. Get out of here as well so that we don't lose it all. Okay. And here my calculator is, which I already have something in here, so I'm going to go ahead and clear that real fast, which if you already have something in your y equals, just click y equals cleared. So if we're looking at it's 14 on my page, the modeling with quadratics, the first question, you're going to want to type in -16x, which I would hit this square down here, but you can hit the caret button and hit 2, which, and if you do hit the caret button, you may be stuck up here. Just click your arrow down and you will come down. And then plus 120x. So we'll go ahead and click graph. So, and this is kind of a important part with the windows that we're looking at here. So we see that there's a graph on here, but we really can't see everything. So we could come in here and change our window directly. I'm probably just going to go and click zoom out so I can see. Ooh, I guess it's a really big one. Maybe I should have gone on and changed my window, but we're asking for when we're going to turn to the ground. So another thing that we could do, because we're really just looking for our x-intercepts, we can go and find those, which we actually won't find it because we're at a half. So you can see that it's between 7 and 8. So let's go ahead and click Zoom 6, which will take us back to our standard viewing window because you can see it right here. If you hit second trace, 0 also stands for x-intercept, so you can go down to 0 and click enter. And it says left bound, which we're not really needing 0, 0 here. We're really needing that other point. So I'm just going to keep clicking this arrow button until I see my cursor again, which should be coming up here soon. Okay, so there it is. So let's go back once because we've got to be at the left side of it. And we'll click it again and be at the right side. And then it says guess. Just click enter again, and there you go. It tells you that our x equals 7.5. So at 7.5 seconds, we will hit the ground again. So then we're asked if we're going to hit the ground again for the baseball. So let's go back to y equals. Let's change our equation. We have negative 16 plus, oops, I don't want 2, I want 15. 15x plus 5. And again, we're going to hit graph. We probably won't, oh, we do see the entire with this one. So sometimes you get lucky. So we'll hit second trace, go down to number 2 and hit 0 and click enter. So we want to be on the left side of it. So let's come over here, enter, get on the right side of it, click enter, and go ahead and click enter a third time just for your guess. And there it tells us at 1.198 seconds, we are at our 0, which y equals is that 1e negative 12. And that is very, very, very small because that's 0 point, bunch of zeros, 1. So it's close enough to the 0 that we're going to call it good. Whenever you are looking at these and taking your test, you can click second trace and also calculate your maximum or minimum. You do have to recognize which one it is. So we can calculate the maximum of this one real fast. And then just click enter again for your guess. And there would be our maximum point for this graph. Let's see, is there anything else you'll really need from here? Really not. That should be, oh, we can hit second table and look at our values. So if you need another point, you can always come here and look. And I believe that our vertex is between 0 and 1. So I would probably grab like 0 and 1 as a point because then they both start going down. If you have any questions before you take your test, message me on Remind. Y'all can use your review packet on your test. So I hope you wrote down all the right answers. You can go back and watch this video if you need to. Good luck on your test. Click the link. It does have an end date, so please make sure you're taking your test on time. But other than that, I think y'all are good to go. I have updated grades. I will keep updating them. I put zeros in for Matthew already for the first 2 workspaces just because a lot of people are getting very behind, and maybe some zeros in the grade book will motivate you because that motivated a lot of people last time. So, but good luck on your test. Finish your Mathia. Distance learners that are responding no to my QR codes with if your Mathia is done before you're taking your test, I would go ahead and get your Mathia done. That was supposed to be, if you're an A person, you're supposed to have that done before your test, and we did that in class today. So you were supposed to do it at home today, so you should have gotten it done today before you filled out that QR code. Okay? If you have any questions, message me, let me know. I have my Zoom calls in the morning from 7:30 to 8:10. If you need the link, email me. You should have already gotten an email from me with it, but if you need it, let me know. All right. Good luck on your test.